Okay, welcome back to the second recording from our marine invertebrates. The last recording, we looked at the origin of life, what life is, what very simple life is, a bit of a timeline for life on the planet, and um, then also what evolution is and how it works. And so my goal for this class and for you is to be able to build from very simple up to the complex diversity of the inverts that we see when we're diving around in the marine environment or sampling from deep water. And I want you to be able to sort of recognize all of these animals and how they fit into the big picture, both evolutionarily as well as how they fit into the ecology of that particular environment. So that is my design for the course, and we are going to continue with that overview, basic um, nature, by starting to look at the difference between what it's like to live on land versus in the water. We know pretty well what it's like to live on land because we're land animals. We breathe air, and as much as we swim around, we still need to come up on dry land to have a good sleep. Um, what is it like to live in the water, though? Well, first off, things move um, often at a much slower rate because of the density and viscosity of the seawater. If you fall off your skateboard as you're skateboarding the um, down the slope of the beach, okay, underwater, you're not going to fall very hard, okay? And I know there might be a couple of surfers that would beg to differ, saying that they've fallen hard, but they've fallen hard through the air, and the water, even if it has collapsed on them, has been at a much slower rate than than air will allow for passage. So the density of seawater being 800 times that of air, it also means that there's more buoyancy. Okay, so things that would sink in the air will float in water. Okay, you can drop a piece of styrofoam and it'll fall to the ground, but it'll float up in the seawater. Terrestrial organisms have to maintain a higher rate of hydration on the inside than the outside. And that's not a problem if you live in the water. You don't have to worry about desiccation. You don't have to worry about having a thick skin that will help you hold on to moisture. Okay, water carries an abundance of nutrients. Okay, so here we have, and food as well. Here we have a couple of guys wrestling in spaghetti, but so there's kind of, you could say that they're kind of surrounded by their food. Now, in terms of the aquatic environment, then all of the things that absorb nutrients are surrounded by their food on all sides. And so they can be single-celled plants or microalgae that can just absorb the nutrients they need right out of the water around them. Whereas terrestrial things need to grow roots or eat their food, go foraging and find their food. Uh, of course, animals don't absorb nutrients out of the water. So if you say that there's an abundance of nutrients um, uh, for let's say barnacles to survive on a wall, that'll be marked wrong. Barnacles have to eat particles that are carried in the water column. Um, the temperature fluctuation is quite different on land versus in the water. So here we have something like a desert at the top where you can get to 150 degrees Fahrenheit or over 50 degrees Celsius and down to -70 below Celsius in the Antarctic. There's a picture of the same habitat Those were two different habitats in the last slide. This is exactly the same habitat in summer versus winter. And look at the difference between the extremes of temperature here. We have probably negative, there would have been negative 40 where I lived, where I grew up in upstate New York, and we would have had temperatures over 100 degrees, so in the mid 30s in the summer. So very extreme differences between winter and summer. What about the water? Here, let's say in the Bay of Plenty, we might get a difference between 24 at the very hottest that the water would ever get up to and down to absolute difference would be 12 degrees. Our absolute lowest would be 12 degrees. So we're really not talking about a massive difference. 12 degrees of water temperature is not huge compared to the temperature difference that you can get on land. And that's because air requires a lot less energy to change the temperature than water due to its density. So land organisms, how do they reproduce? They generally reproduce through either, well, generally sexually. So they'll recombine and then they'll have seeds that are distributed by falling or by other organisms, or they produce offspring that can move away themselves. Aquatic organisms generally reproduce in a different way, or most of them. Most of them have a planktonic larval stage. So they have a sexual reproduction, but what they do is they just expel either their sperm or their sperm and eggs up into the water column, and hopefully those sperm and eggs find each other, fertilize each other, and then off they go, drifting around in the plankton. So this is the way that the offspring don't land right next to the parents and compete directly with the parents. Most of those planktonic larvae are planktotrophic, which means that they eat other plankton. They're feeding on each other. Some of them are lithotrophic, which means that they have a yolk sac attached. Okay, and that takes more energy to produce a yolk sac, and so you produce larger larvae, but hopefully their survival rate will be higher.